Hello students of class 9. In this session we are going to discuss about three things. One is true solution, second is suspension, and third is colloidal solution. Now when we talk about solution, we have two components. One is solute, the other is solvent. Now in convention, or I will say in conventional method, we consider the substance that is present in less amount to be the solute and the substance that is present in more amount to be the solvent. So solute and solvent form solutions. Such a solution is actually termed as binary solution. So in higher classes, you will come across other terms where it is not always necessary that a solution will always be having two components. But if a solution has two components, solute and solvent, such a solution is termed as binary solution. Now, what is a true solution? A true solution is something where the solute particles are completely dissolved in the given solvent. Now, when these particles of solute are completely dissolved in a given solvent, you even cannot see the particles of solute under a microscope. So, such a solution is known as true solution. Now, if the solvent is water, then this can be termed as aqueous solution. And if the solvent is not water, then you can term it as non-aqueous solution. The term aqueous goes with water as a solvent. Now, in case of true solution, the size or the dimension of the solute particles are almost equal to 1 nanometer, which is equal to 10 to the power of minus 9 meter. So for this reason, the solute particles are very, very small, and if you try to filter it, if you try to separate the solute particles from the solvent, you will not be able to do so because the solute particles will pass through the pores of the filter paper because it is of very, very small dimension, 1 nanometer or 10 to the power of minus 9 meter. Now, for that reason, you cannot separate the solute particles from the solvent in a true solution by the method of filtration. Now, I also said that you cannot see the solute particles under a microscope, even under a high power microscope, because it is completely dissolved. So if and only if a solute particle is completely dissolved in a given solvent, it forms a true solution. And since the particle size is very small, it is not capable of scattering light. And the phenomena of scattering light by particles is known as Tyndall effect. You can see Tyndall effect in forest where the light seems to be scattered and you can see the path of the light. So this Tyndall effect is not visible, is not seen in true solutions. True solutions are extremely stable and the solute particles do not settle down, do not separate out from the main solution. Now, in comparison to all these properties, what is a suspension? Suspension means the solute particles are having very high dimension. Almost 100 nanometer size is the size of the solute particles in a suspension, for which you can separate the particles of the solute in a suspension by ordinary method like filtration, where the size of the solute particles are greater than the size of the pores of the filter paper and they do not pass through the filter paper. Thus, they are unstable. Why? Because if you keep a suspension, say you have taken sand, you are trying to dissolve it in water, will it get dissolved? Of course not. If you are taking chalk powder, you try to dissolve it in water, will it dissolve? No, not at all. So what will happen if you keep that beaker containing chalk powder and water? Obviously, after some time, the chalk powder will settle down at the bottom of the beaker. And this actually proves that a suspension is unstable. And why do we say it is unstable? Because the particles of the solute has got separated from the main solution and the particles of the solute are not getting dissolved in the solution. Such suspensions are showing Tyndall effect. Why it is showing Tyndall effect? Because of the large size of the suspension, the solute particles. On account of the large size of the solute particles in suspension, they are capable of scattering light. They are capable of showing Tyndall effect, and hence the entire path becomes visible when you pass light through a suspension. Now, what is a colloid then? The colloid particles are having dimension, or rather the solute in a colloidal solution is having dimension in between a true solution and a suspension. So I can say in between 1 nanometer and 100 nanometer dimension. So for that reason, these particles are having properties, rather you will say in between true solution and suspension. But keep in mind that though colloidal solution appear to be homogeneous in nature, they are heterogeneous, because you can actually see the colloidal particles, the dispersed particles in the dispersion medium under a very high power microscope, though not in a simple microscope. Now, colloidal particles also show Tyndall effect. They are capable of scattering light and thus makes the path visible if you pass light through it. So, let us explore some more properties of such solutions in our discussion. So, solution is containing two components. One is solute and the other is solvent. Now keep in mind that if there are two components in a solution, such a solution is known as binary solution. Why binary solution? Bi means two and binary actually means two component. So it is known as binary solution. Now the substance which is dissolved in a liquid is called the solute, and the liquid where you are dissolving the solute is known as the solvent. Now, if I take two components, it doesn't mean that it always has to be solid solute in liquid solvent. You know what? That the type of solvent you are taking, that decides what type of solution it is. If I say it is a liquid solution, that means the solvent which I have taken is a liquid. So I can take solid solute in a liquid to form liquid solution. I can take liquid solute in liquid solvent again to form a liquid solution, and I can take gaseous solute in a liquid to form liquid solution. So there are three types of liquid solution: solid in liquid, liquid in liquid, and gas in liquid. So you can say then, ma'am, can we prepare solid solution? Yes, of course we can prepare solid solution. For that, the solvent needs to be what? The solvent needs to be solid. So in that case, the solution will actually behave as solid solution. So I can take solid in solid. This is my solute. So I can take solid in solid, liquid in solid, gas in solid in order to get a solid solution. Similarly, if I have to prepare gaseous solution, then I can take solid in gas, liquid in gas, and gas in gas. Regarding all these things, you will be studying in your higher classes. So as of now, you need to focus about liquid solutions and binary solution. That is a solution containing two components, one of which is a solute and the other is a solvent. Now keep in mind that if your solvent is water, okay, then in that case, I will say that the solution is aqueous solution. It is aqueous solution. Now this term aqueous means what? Water is acting as the solvent. If the solvent is not water, that means apart from water, any other solvent is taken, then such a solution is termed as non-aqueous solution. It is known as non-aqueous solution. That means the solvent is not equal to water. Then it is non-aqueous solution. One more thing, keep in mind that the solute particles are called dispersed particles. The solute particles are called dispersed particles. Why they are called dispersed particles? Because they are remaining dispersed in the solvent, and the solvent is known as dispersion medium. So these two terms keep in mind, that in a solution or in a binary solution, you have two things. One is the solute and the other is the solvent. Now this solute is known as dispersed particles. The particles of the solute remain dispersed in the medium, and so they are known as dispersed particles, and the particles of solvent are dispersion medium. They are dispersion medium. That is, in this medium, the solute particles are remaining dispersed. And I said that if the solvent is water, then such a solution is termed as aqueous solution. And if the solvent is not water, then that solution is termed as non-aqueous solution. Okay, so this is what I have said. Now, these are the examples we are seeing. Salt is a solute. Types of solute. Copper sulfate can act as a solute. You can dissolve it in water. Now, water is the most common solvent, and if water is the solvent, it is an aqueous solution. Here it is written it is an aqueous solvent. I will prefer all of you not to write aqueous solvent, because the solution is an aqueous solution when the solvent is water. I hope you understand. Now, acetone is an organic liquid. Remember that if I say non-aqueous solution, then it can be any organic solvent. It can be any organic solvent. In the previous module, you have seen that sulfur dissolves in carbon disulfide. So CS2 is acting as an organic solvent. Now acetone can act as an organic solvent. Benzene can act as an organic solvent. Now CCl4 is carbon tetrachloride. It can act as an organic solvent. These solvent, when you take solute dissolved in these solvent, then it will form non-aqueous solution. So keep in mind that organic solute dissolve better in organic solvent, because like dissolves like. That means the nature of the solute and the nature of the solvent, if it is similar. If I take a polar solute, then I have to take a polar solvent in order to make the solute dissolving in the solvent. So polar solute will dissolve in water and such solution will be aqueous solution. Non-polar solute will dissolve in organic solvent and non-polar solute generally is organic solute. And what I said for CS2, it is known as carbon disulfide. It is carbon disulfide. And CCl4 is carbon tetrachloride. Tetra means 4. So it is known as carbon tetrachloride. These are acting as organic solvent. These are acting as organic solvent and they form non-aqueous solution. Okay. So the solutions made by dissolving various solutes in water form aqueous solution and the solutions made by dissolving solutes in organic liquids are non-aqueous solution. Now solution is a homogeneous mixture of two or more substances. If I say two, then it is a binary solution. If it is more, then it can be trinary solution, quaternary solution, etc. Now, a homogeneous solution means the solute is completely dissolved in the solvent and it forms uniform composition throughout. Okay, now homogeneous mixture means the mixture is just the same throughout. What does it mean? Homogeneous solution means two things I said. Homogeneous solution means the solute is completely dissolved. Solute is completely dissolved in the solvent. And another thing which I said is what? That it has uniform composition throughout. It has uniform composition throughout its solution. Okay, uniform composition throughout. So obviously for heterogeneous solution, the properties will be different. The solute will not get completely dissolved in the solvent. The composition will not be uniform throughout. What does it mean, uniform composition throughout? Suppose you have taken a solute in a solvent and you see that it has occupied the interparticle spaces, and now you take any part from the solution, you will see it seems to have same composition all over. That is known as uniform composition throughout. Now types of solution. Now I said that it can be what type of solution. Here if you see, if I take liquid as the solvent, then it can be solid in liquid, liquid in liquid, or gas in liquid, right? That is what I have said. So let us see that in this part. Yes, so coming to this part, it can be salt solution, that means salt in water, solid in liquid. Sugar solution, sugar in water, solid in liquid. Vinegar, what is vinegar? Acetic acid in water, liquid solution, liquid in liquid. So metal alloys, that means metal alloys are is what? Solid in solid solution. Air is gas in gas solution. So let us see. If I say salt solution, then salt solution has what? Solute is salt, it is solid, and the solvent is liquid, which is water. And this type of solution is a liquid solution. Now if I say vinegar, vinegar means here the solute is acetic acid. Solute is acetic acid, and acetic acid is in liquid phase, and solvent is liquid, which is water. Solvent is water, which is liquid. So this is liquid in liquid solution, and it's an example of liquid solution. Why? Because the solvent will decide what type of solution it is. So it is liquid solution. Here again, it is example of liquid solution because the solvent is water. But here again, if I talk about brass, copper and zinc forms brass that we have seen in the previous module. So solute is a solid and solvent is also a solid, and such a solution is known as solid solution, where the solute and the solvent both are in the solid phase. Now if I say air is a mixture of gases, we know. Then what happens? Gas in gas. So gas can be the solute. Again, the gas can be the solvent. Dust particles are also suspended in air, we know. But if I say gases in air, then it is an example of gaseous solution. Why? Where a gas is a solute and a gas is again a solvent. Okay. So, a true solution is something which is actually completely dissolved. Okay, some examples, seawater. Why seawater? Seawater contains salt, no? So salt is dissolved in water. Copper sulfate solution, a blue color solution. See, copper sulfate is CuSO4. If CuSO4 you take as a solute and you take water as a solvent, then the solution will be of blue color. Now this, if you take, then the solution will be of blue color, blue solution. Why? Because the crystals of copper sulfate are completely dissolved in water. Alcohol and water mixture, that forms again a homogeneous solution. Okay, alcohol dissolves in all proportion in water. The reason you will study in class 12 that on account of formation of intermolecular hydrogen bonding. If you are unable to understand as of the level of class 9, no need to worry. Just keep in mind that alcohol acts as the solute and water acts as the solvent, and it dissolves in all proportion, and so this forms a homogeneous mixture, or rather I will say it forms a homogeneous solution because it is completely dissolved in water. Now soda, water, soft drinks, Coca-Cola, Pepsi, Thumbs Up, all of this, they have what? They have carbon dioxide dissolved in water. So they are known as aerated drinks. Okay, these soft drinks are known as aerated drinks. And why they are known as aerated drinks? The reason is in such drinks you have CO2 compressed in water. So CO2 is a gas and H2O is a liquid, where CO2 is compressed under high pressure. The solubility of CO2 increases in water and this forms a solution, and it is a homogeneous solution of gas in liquid. And what type of solution it is? It is a liquid solution. And if it is asked in your level of class 9, you will say the type of solution is homogeneous solution. Now what is the solute? The solute is the gas CO2, and what is the solvent? It is water. Okay, now I was talking about copper sulfate dissolving in water, giving a blue color solution. This example we can see over here. The copper sulfate crystals are getting added, and if you stir it, you dissolve it uniformly. Even if you don't stir it, with time it will automatically get dissolved and will give you a blue color solution, but it will be time taken. If you stir it, what happens is you increase the kinetic energy of the particles and the dissolution process becomes faster. Now the properties of the solution, what type of solution we are talking about? True solution. True solution means a homogeneous solution. What is a true solution? A true solution actually means a homogeneous solution. And what is a homogeneous solution? Homogeneous solution is such solution where the solute particles are completely dissolved in the solvent. They are completely dissolved in solvent, forming or having uniform composition throughout, So I think what is a true solution is clear to you. Now, a solution which is a true solution is homogeneous mixture, we have said. Now, in the introduction part, I told the dimension or the size of the solute particles in a true solution is less than 1 nanometer in diameter, or maybe ranging up to 1 nanometer. It's better if you remember that it is less than 1 nanometer, and it can be less than 10 to the power of -9 meter. That is the size of the solute particles. And so you cannot see them even with a microscope. Under high power microscope also you cannot see, and under simple microscope of course you cannot see. The particles of the solution pass through the filter paper. Why it passes through the filter paper? Because the dimension of the solute particles are less than the size of pores of filter paper. They are less than the size of pores of filter paper. So what will happen? The particles of the solute will pass through the pores because they are smaller in size, and obviously such solution cannot be separated by the method of filtration. The solutions are stable. When do we say the solution is stable? When the solute particles do not separate out from the solution. The particles of solute present in the solution do not separate out on keeping. They will not settle. They will remain dissolved in the solvent. So they are stable. So homogeneous solution, what I said, true solution forms homogeneous solution. They are completely dissolved in solvent. They have uniform composition throughout. And one more thing is, such solutions are stable solutions because the solute particles do not separate out from the solvent on keeping. So a true solution do not scatter light and does not show Tyndall effect. So another property is doesn't show Tyndall effect. You know what? Tyndall effect is an effect which is known as the scattering of light. It is the scattering of light by particles. Okay, scattering of light by particles. Of course, the particle size should be large enough in order to scatter the light which is made incident through such solutions, and true solution are unable to scatter light and show Tyndall effect because the particles of the true solution, the solute particles, are very less in dimension, almost 1 nanometer or less than that. So types of solution, I said solid in solid, alloys forming brass was one of the example which we have already discussed. Now next let us see solution of solid in liquid. We have already discussed solid in liquid. It can be sugar solution, salt solution, and then solid. They are known as solid in liquid. Now a solution of iodine in alcohol is known as tincture of iodine. You may be asked what is tincture of iodine. Tincture of iodine means Tincture of iodine is a solution of iodine in alcohol. It is a solution. Iodine is I2 in alcohol is known as tincture of iodine. Obviously, I2 or iodine is acting as the solute and alcohol is acting as the solvent, which is liquid, and iodine here it is taken as solid. Okay, solid solute. So this is an example of solid in liquid solution. Solid in liquid solution. Iodine dissolved in alcohol. Seeing liquid in liquid, vinegar, we have already discussed acetic acid or ethanoic acid in water. Okay, so vinegar. Now there are two types of vinegar. Fruit vinegar, non-fruit vinegar. Fruit vinegar is obtained by fermentation of fruit. Yes, and non-fruit vinegar is acetic acid dissolved. That's a synthetic vinegar, which is acetic acid dissolved in water. Now, acetic acid is also known as ethanoic acid. It is known as ethanoic acid, and it is dissolved in water. So keep in mind that acetic acid or ethanoic acid is the solute and water is acting as the solvent. So it is an example of liquid, which is ethanoic acid, and solvent water, which is also liquid. So it is liquid in liquid solution. And you must see that acetic acid or ethanoic acid has a formula like this. It is CH3COOH. This is the structure of acetic acid, ethanoic acid, containing 2 carbon atoms. So I can say it is C2H4 3 plus 1 4 O2. This is ethanoic acid, CH3COOH. Next, solution of gas in liquid. Gas in liquid, soda water, aerated drinks, carbon dioxide compressed under high pressure in water. Gas in gas, I told you air, is a mixture of gases. Okay, so here again we can say gases like oxygen, argon, carbon dioxide, water vapor, etc. in nitrogen gas. Now why nitrogen gas? Because that is present in greater amount. So nitrogen gas is acting as the solvent when I talk about air. So if I take air, then other gases, even water vapor, it is acting as solute. And what is the solvent? In air, the solvent is nitrogen gas. Nitrogen gas. So keep this thing in mind. Nitrogen gas is N2. Nitrogen gas is N2. Next, moving on to suspensions. Suspension, in the introduction part, I have already said that it is a heterogeneous mixture where the particles are actually not dissolving in the liquid. It is not dissolving, without dissolving in it, like chalk in water, clay in water, milk of magnesia. You know, milk of magnesia, let's see this. Okay, let's come back to this page. Milk of magnesia is what? It's an antacid, you know. Milk of magnesia is an antacid. You should keep these things in mind for class 10 also. Milk of magnesia is an antacid. Okay, and this is an example of a suspension. If you see a bottle of milk of magnesia, it is written, shake the bottle nicely before you. See, milk of magnesia, it's a suspension of magnesium hydroxide in water. Okay, and the solid particles and water remain separate in a suspension. So milk of magnesia is magnesium hydroxide. It is magnesium hydroxide as the solute and the solvent is water. Solvent is water. Okay, so solvent is water. Now magnesium hydroxide has a formula MgOH whole twice. This is magnesium hydroxide. This is magnesium hydroxide. If it is taken in water, this is in a solid form and this is in a liquid form. It is made to remain in a suspended form. When you have to take it, you have to shake the bottle before use, and what I said is it acts as an antacid. Okay, it acts as an antacid, milk of magnesia. Now studying the properties of suspension. Let's study the properties. Suspension is a heterogeneous mixture. This I have already said. It is an heterogeneous mixture. It is a heterogeneous mixture. The particle size is larger than that of the solute, true solution, even larger than that of colloidal particles, and it is what? It is larger than that of 100 nanometer in diameter. So if I say 1 nanometer, let's see, if I say 1 nanometer or maybe less than that, that is a true solution. From here to 100 nanometer, then this is a colloidal solution, colloids, and greater than 100 nanometer, the particle size of solutes, form suspension. So if the particle size of solute is less than 1 nanometer or 1 nanometer, it is true solution. It is a true solution. Now if it is greater than 100 nanometer, it is suspension, and in between 1 nanometer to 100 nanometer size of the solute particles, they are colloidal solution. So colloids are actually what they are. They appear to be homogeneous, but actually they are found to be heterogeneous under high power microscope. It is not a true solution. Example: soap solution, starch solution, milk, blood, ink, jelly, solution of synthetic detergents, all these things. Okay, so let us see the properties of colloids. What are the properties of colloids? See, this figure is showing the Tyndall effect. Okay, here till this is the Tyndall effect. Beam of light does not scatter when it is passed through a true solution. The path is not visible. See, the path is not visible, but the beam of light scatters and the path is visible when it is made to pass through a colloidal solution. So in a colloidal solution, the particles are big enough to scatter light. The reason for scattering light, the reason for the Tyndall effect was what? The reason for the Tyndall effect was the particle size. Okay, it was the particle size of the solute particles. If it is large enough, then it will be capable of scattering light, and the phenomena is known as Tyndall effect. And on account of this phenomena, the path of the beam of light will be visible. Okay, so let us see the properties. Colloidal particles appear to be homogeneous, but actually it is heterogeneous. You can observe this under a very high resolution, very high power microscope. The particle size of colloids are in between 1 nanometer and 100 nanometer in dimension of the diameter of the solutes. What is the diameter? Diameter, this is a circular shape, the diameter is this. Okay, twice the radius is the diameter. Okay, so it is seen under high power microscope, but it cannot be seen under a simple microscope. The particles of a colloid, they can pass through the filter paper. So actually you cannot separate these particles by physical methods like filtration. Why? Because the size of the colloidal particles are 1 nanometer to 100 nanometer, and they pass through the pores of the filter paper, because the pores of the filter paper are larger than these particles. Now the colloids are quite stable. I told you stability depends on the fact that the solute particles are not separating out from the solvent. So obviously this means the particles of the colloid are not separating out from the solvent in its own solution. A colloidal solution is capable of scattering the beam of light, and hence they are showing what? They are showing Tyndall effect. Now this figure, the picture shows the suspension and colloids. It is showing suspension and it is showing colloids, and it is showing the Tyndall effect. See, a torch is being lit, no? So when you see a colloid, when you see a suspension, the path of the light is visible, but for a true solution, the path of the light is not visible. This is showing the difference in the properties of true solution, colloids and suspension. So let us see classification of colloids. Colloids do not involve only solids and liquids. They may also involve gases, not only solids and liquid, but also gases. Okay, according to the physical state of the dispersed phase, that is the solute. So always keep this thing again in mind. In case of colloids, you have two things. One is dispersed phase, and this dispersed phase is what? It is the solute particles, which is the dispersed phase, and the dispersion medium. The dispersion medium means the medium where the solute particles are dispersed. So we can say the solvent. So dispersed phase is the solute in the colloid, dispersion medium is the solvent in the colloid, and they have 7 groups. We can see 7 groups. In higher classes you have these things: a solid sol, aerosol, emulsion, foam, solid foam, gel. These all are examples of different types of colloids. So let us see one by one. What is a sol? Sol means the colloidal particles in which the solid particles are dispersed in a liquid medium. So if the solute is solid and the solvent is liquid, it forms a sol. Okay, solid, solute, liquid, solvent forms a sol. Example: ink, soap solution, starch, paint, they are all sol. Solid sol. Solid sol means solid particles and in a solid dispersion medium. Colored gemstone, ruby. Okay, that forms solid sol. So solid in solid will form solid sol. Okay. So next, aerosol. What is aerosol? Okay, so aerosol means what? A solid or liquid which is dispersed in a gaseous solvent. So this is known as aerosol. A solid or a liquid solute which is dispersed in a gaseous solvent is known as aerosol. Examples of aerosol: smoke is aerosol, which is soot in air, carbon particles in air. Aerosol, smoke is one example I told you. Automobile exhaust is another example. Hairspray, you people may be knowing hairspray, it is an aerosol. Okay, so these are the examples. Emulsion. Yes, this is another example which is important. What is emulsion? You know, emulsion is milk, butter, face cream. They are emulsions. Okay, vanishing cream. Face cream is known as, these are in the market, they are known as vanishing cream. Okay, so an emulsion is a colloid in which the minute droplets of one liquid is there in another liquid. So solute is liquid, the solvent is again liquid, it forms it forms emulsion. Now foam, what is foam? Foam means the solute is gas and the solvent is liquid. That is forming foam. The shaving cream, this is a foam. Okay, beer foam, this is a foam, you have seen. So now, uh, gel. What is gel? Gel means a semi-solid colloid in which a continuous network of solid. So solid or semi-solid dispersed. Okay, that is known as gel. So let us see, dispersed in a liquid, that is known as gel. So what is a gel? Gel is solid dispersed in a liquid. So solid solute dispersed in a liquid solvent is forming gel. I hope the concept was quite clear. If yes, then do comment in the comment box. And if you have any query, if you have any doubt, please put it down in the comment box and I will be replying to it. Thank you all of you. In the next module, we are going to discuss about concentration of solutions. Bye all of you.